Hello. Welcome back to Advancing Spark, where apparently I've been causing a load of controversy recently because I did the conference talk last week at SQLBits, a big old data conference in the UK. Now, the topic of the talk was how you can use AI in engineering to get ahead of the curve. Because honestly, I keep having conversations with people going, is AI coming for my job? Will engineering still fundamentally exist in a few years? Is AI going to take over the world? Which is a valid concern that a lot of people in all tech have. People vibe coding and doing all that kind of stuff to take away web design jobs. People generating images to take away graphic design. It is happening across the industry. So it's a valid concern that people in engineering are going, is it going to happen to me? That was the point of the talk. And a lot of it is about actually, here's kind of where we see products and things emerging onto the market. It's actually going to affect you a lot after, because there's a long tail of adoption before something comes out when it actually starts impacting people. But there's a lot of stuff you can start doing now or in the next year or two to get ahead of it, and then you won't be impacted. That was the point of the talk. However, there was one big slide of that talk that was, someone took a photo, said some nice things about the talk actually, but then that was taken massively out of context, and I've been, brigaded by fans of a couple of famous LinkedIn data engineers who, obviously, if they see something saying this is dead, deride it and mock it and treat it with scorn and then turn everyone against it. And that's the interesting thing, because it's what we do when we are scared. We go, no, it's never going to happen to me. And it's the same reaction I've had from lots of engineers with AI. Why people aren't using AI, even though people who use AI are going to get further ahead. Now, load of context you need for this. That's the point. I'm more than happy if I take you guys through the arguments I was making and the reasoning I made for that talk. If you still disagree with me, you want to call me a clown, call me an idiot, that's cool. That's what I get for having opinions on the internet. But at least just give it a chance with a little bit of context. So I put together a smaller, cut down version of the talk. I'll walk through the main points that I was making and then see what you guys think. See if you still think I'm wildly off base. Now, driven behind this, obviously we've just had the Databricks Data and AI Summit, just had the Snowflake Summit, loads of big vendor conferences have just happened. Lots of these things, I've kind of used examples from the Databricks Summit just as examples of going, see, it's happening. These tools are already actually out and you can use them. It's not things people are making up in some doomsaying prophet of doom kind of thing. The difference is how big an impact you think these tools are going to have. But yeah, let's just walk through some of the points I was making and just see if you think it makes any sense whatsoever. Why not, hey? So, firstly, I know why the first slide caused the controversy. Saying anything is dead is obviously going to cause a lot of controversy. I put this up to kind of shock people, kind of wake people up, and then to talk about a different point. So data engineering, as we currently call it, is going to fundamentally change. If what you say you do data engineering now is, I tweak pipeline script to make it go faster. I do performance tuning. I manage storage layouts. I do all the things. I mean, yeah, I'm being quite specific around Spark and lakes and things here, but loads of the jobs specifically in that remit is already starting to be automated away because people like Databricks are starting to make it commodity. They're starting to say, no, well, just use serverless. We'll do performance tuning. Let us do predictive optimization and manage the storage layer. There is already a marked change in how much of the old stuff that you have to do. So data engineering isn't dead. But some of the things that we currently do now, we're not going to need to do in 4 or 5 years. The same as code I was writing 10 years ago. I don't have to write that same syntax or code or even language anymore because tech is change. That's the point. Data engineering is fundamentally going to change in the next few years. If it doesn't, we'll find it really hard to adapt and survive as an industry, let alone individually get jobs. Now, part of this is driven because I speak to loads of engineers. And that question of what do you do? What do you do as an engineer? What is your purpose? If someone says, what do you do as a career? What do you say? And loads of engineers focus on the tech. They say, I make pipelines fast. I'm really, really good at optimizing pipelines for massive terabyte, petabyte data scale. I make pipelines go fast. Is the kind of the quick and easy thought that a data engineer comes to. Now, that's not actually what we do. What we do is we get data in the hands of the people who need it in the timeliness that they need it, in the size they need it, with the speed they need it for the right cost. It's about supplying people or jobs or AI with the right data at the right time. Now that's been complicated for years because of mad bursts in terms of what we could do. We've had fundamental technical shifts that changed the way that we approach things. That meant that we had to go on technical diversions to get it to actually work and function. We've achieved a ton over the years. But fundamentally, what we're doing is getting data into the right hands. So will data engineering still exist? Well, yeah, your concept of data engineering is getting data into the right people's hands, of course. Will we have a whole load of mess to clean up caused by AI and automation? Yeah, absolutely. That's not going anywhere. But will you still be performance tuning a script? I imagine you'll be doing less of it. Maybe the odd example, the biggest, craziest one. But if you were working for a company and you're loading thousands and thousands of tables, would you need to performance tune every single one of them? No. There's going to be an element that just happens automatically. That's already happening. So, main point of this was that it's fundamentally changing and we need to make sure we're catching up. Because you don't want to actually get there in a few years and go, oh, the world's changed around me, but I no longer know how to do it. I'm now being outperformed by other people. It's the Luddite story. It's the story of you can either be resistant or you can get with a program, and shock horror, it's not going to go well if you're not embracing change. I'm not saying everyone has to jump on every hype bandwagon, but AI is actually causing a fundamental revolution in terms of the tech industry. So way back in the day, industrial revolution times, someone invented the loom, they could suddenly do the work of 10 people very easily, and they didn't need as much technical skill. Now, people who had been craftsmen and learned from their parents, and there's a whole cottage industry of being able actually to make incredible bespoke garments, were understandably annoyed that someone could pull a lever a few times and create some mass-produced garments. But who won out? Automation. Automation wins because you could do it cheaper, you could do it faster, you could pay people less to do it, factory owners win. That's capitalism. Now, there's going to be parallels when we talk about data engineering pipelines. If you want a handcrafted, artisanal, bespoke data pipeline, great. Not everyone's going to pay for you for it. There will be companies who need that, absolutely. But not every company is going to need it. Not every company is a FANG, gigantic company dealing with petabytes of data. Most companies are not. And, you know, that whole pattern grew with us. The digital revolution, when suddenly people who were amazing at in memory mathematics and juggling numbers and managing sums were highly sought after, highly paid, got easily replaced with the advent of calculators, especially when calculators suddenly were everywhere. You no longer needed the special skill. We've commoditized that tech. Same thing is starting to happen in engineering. Hasn't happened yet. It's going to take a while to happen. It's going to take a long while before people actually adopt it. But we're going through this process. You've got a choice. You can either be the one going, look, it's happening, I want to get ahead of it. How do I make sure I'm at the forefront of this, actually benefiting from this? Or you can go, nah, can't do my job, not going to get there. I'm going to ignore it and sit it out. My worry is that you'll end up like the Luddites. You'll end up, well, one, poo-pooing any idea that comes along that you don't like, but two, being left behind by people outperforming. That is the danger. Now, when I talk about the future, I was talking about the products that we're starting to see enter the market and the ones that we're kind of being teased about where they're going to come. Now, this is the slide that caused all the controversy. This is the slide that a photo was taken of it, shared on the internet, and everyone jumped on the bandwagon saying, this guy's an idiot, this guy's a clown, this guy doesn't know what he's talking about. And it's interesting because I think everyone took this massively out of context. This is about what we're going to start seeing because these products are coming out. Not all of them, maybe not the 4 years one. But we're starting to see the hints about this is the direction vendors are going to start going. So as engineers, how do we actually prepare for this? How do we deal with this going on? Because it's going to start appearing in the companies we work for. Like vibe engineering, that is there now. What do I mean by that? Well, obviously you got vibe coding, got people putting e-com sites live where they've just got ChatGPT to write the code and they're not on any resiliency and they're not protected against DDoS attacks or anything. Well, we're starting to see the same in engineering. You can, two different directions. You've got your slightly prompt-enabled low-code. That's not that scary. We've had low-code citizen ETL for ages. You can drag and drop, move some data around, and yeah, it's slow. It's people moving things, doing it one pipeline by one pipeline by one pipeline. Yeah, they can write a bit of a spaghetti mess of code, but it's not crazy. The other side of things, where people are using coding assistants to generate actual fully functional script and then just deploying that into the ether and going, now well, the data gets there. And then they got another pipeline, so they do it again, then another pipeline. And each one is actually written slightly differently because AI, stochastic model, right? And you end up with pipelines across pipelines that actually have no standards, that have been built by people who didn't actually know what they were doing. You can do that now. Across Cursor, across Databricks Assistant, across any kind of LLM coding assistant, you can generate code and slap it into production. People could do that from Stack Overflow, but it's a lot harder to get it to work. Now you can generate code that kind of works, or at least look like it works. That is something we're going to have to deal with as engineers. I'm not saying you're all going to do that. I'm saying we have to deal with that being done in industry and our organizations. I mean, that's the thing we need to cope with. I mean, fully automated performance, that's where Databricks are trying to go. That's where most people are trying to go. They're trying to take away all the control and all the knobs and dials that you can play with to go, just let us do that. We can put an AI model over the cluster and actually have it scale, which is using information I don't have access to. Databricks can go and do that. Snowflake can go and do that. Anyone building a data platform can go and do that. And now that's getting there. Now, it's not quite there yet. We're starting to see more things come in. Enzyme and that kind of stuff that Databricks are doing is cool. We're going to see more stuff. There's lots of interesting things they're working on. It's not there yet. But more and more, it's going, actually, we can see the kind of queries you run. We've actually re-optimized your table so it's optimized for the kind of queries people run. Yeah, a new query will come in. That won't perform that well. Next time they do it, it'll go faster. That already exists. That is starting to be rolled out. Not mature yet. Give it a couple of years and you'll start seeing it more and more and more and more. When I say 0 to 2 years, these things are going to appear on the market, not necessarily in every single organization. It's a, when are we going to see it? And then figure out when your industry is going to start being impacted by it. AI lift and shift migrations, that already exists. If I've got 1,000 tables living in one system, maybe I'm going from Redshift, I've got 1,000 different stored procs written there, I can run a tool and just remap that to a different language. Change that so it's now running in T-SQL, or change it so it's now running in Spark SQL. These tools exist. One of the ones that Databricks announced, Lakebridge, does exactly that. It's an out-of-the-box code migrator. That's a lift and shift migration. If I had 1,000 tables and they're all rubbish and it was all spaghetti, I'll have 1,000 new tables that are all still rubbish and new spaghetti in a new language. But that tool exists. And that would have been a load of work. That would have actually paid for a load of engineers to be doing that work, doing the migration, even if they were doing a lift and shift migration. That is now a piece of work that has gone. Right, yeah, you can pay someone to do it manually, but why would you if there's a tool that does it automatically? The next one's slightly further out. I expect there to be a huge amount of work recovering from the spaghetti of vibe engineering, especially as it goes more agentic. Especially if people are building agents that build pipelines. Pipelines then just suddenly appear out of the ether. They're left there running. And then as an engineer, you're left there with hundreds and hundreds and hundreds of pipelines written slightly differently that don't make any sense. Now, we can get ahead of that. As engineers, if we see this coming, we can put in frameworks and guidelines. We can look at how these agents are actually building things out and try and make sure that when it builds it, it actually follows our standards. It puts the data in the right place. It does whatever hops it needs to. Start to question, do we need to do those things still? But I assume yes. But that's work that we need to do. We need to think about this. It's too late if we think about this in 3-4 years when it's already a mess. And we go, oh yeah, we should have probably fixed that, shouldn't we? This is the kind of thing we need to get ahead of. Like full AI ETL development, yeah, I mean, we're at the point you can ask an agent to go and get some data and do some cleaning and land it somewhere. People aren't really materializing it. This seems like a quick one-off kind of toy. That is going to be maturing. People are going to do it more and more. The whole Databricks Lakebridge announcement of the being able to spin up a database, do something with it, trash it, and the whole single-second spin-up of a new database, because they're expecting it to be the backbone of a lot of agentic workflows, kind of hints along the direction they're going. They're expecting agents to spin up loads and loads of stuff, use it, and then trash it. And they're kind of going that way with just getting data into the right place. How much will it actually be adopted? How much will we actually see it in our workspace? Well, it's going to take a while, but these tools are going to start entering the market. People are going to start building production version of these, and we need to prepare. Same as refactoring migration. Sure, we've got lift and shift migrations out now, but actually going, well, don't take it from 1,000 store procs. Turn it into a nice metadata-driven, properly orchestrated framework, whatever your choice of data engineering pipeline looks like. having it so it goes into the right state and optimizes it, it's not even that hard to do. We're just not seeing many of them yet. We're going to be seeing those out on the market. So if you make your work as an engineer by migrating between platforms, it's going to get automated in a few years. Not immediately, not the moment that's released. Again, always an offset before it actually hits your industry. Finally, yeah, 4+ years away, full autonomous data going, I need data, go and find it for me. Yeah, I mean, all of these things, the end-to-end, actually, could I build something that finds the right source system according to my documentation, assuming I have documentation, does some data cleansing, lands it in the right place, does some data modeling, pushes it out somewhere. You can see that working. Not for everyone, not for every use case, not for every nuanced, oh, but what about that file type or that source system or that odd esoteric use case? But it's going to start coming for some. And if as an industry, if, I don't know, what, 40% of the low-hanging fruit suddenly gets automated, you think we're all going to still have the same amount of jobs in industry? Maybe not. We need, unless we have shifted and we're actually starting to tackle more of these things. We're building these autonomous data platforms. We're building out the frameworks that these things can live in to make them good. We're building the next big thing. We just need to have our eye on what the next thing is so we can keep moving as an industry. That's the point of this stuff. Not doom and gloom, go and give it up and go find another career. It's a get ahead of this stuff and you'll have loads of work in the future. Now, a few quick examples of that kind of thing. I got a terrible low-quality GIF for the Databricks assistant, but it's almost like highlights how terrifying vibe coding is. I can ask it a question, and it'll generate some bad code for me. Sometimes it'll generate good code. It generates better code the more descriptive I am. The better I am at my job, the better I can make it generate code for me. Again, there is a purpose for us, the data engineer, in this. But it means one data engineer can do far more work than we used to, which is a challenge. Slightly better one on the whole vibe coding a low-code pipeline. I think Databricks demoed a couple of weeks ago. It's not actually out yet. It's in preview. We're going to start seeing it more and more. But that low-code, again, required me to get a different platform. This just typing and saying, hey, figure out the low-code for me, is even more accessible. And we're going to see people doing it. But we're going to see just variations about how people do it. We're going to see people spinning up their own thing and doing it as a cottage dark data industry. We just need to get ahead of this to make sure it's done properly. Otherwise, we'll have this. We'll have the whole spaghetti mess of everything that's going on. There's just work to do to make sure we are actually prepared for this stuff. So what should you be doing? Well, number one, engineers should be using AI to do engineering. Not to say you should be handing it all off to AI and you don't do anything anymore. It's the judicial application of AI will actually make us better at our jobs. And it's one of the interesting things that people don't really think about. This is kind of a slide from Gartner kind of early this year. I copied and made simple. So when you talk about an AI use case, when someone says, what are you using AI for? Nearly all of the times they're doing the upper part. They're going, well, I'm solving a customer problem, a business problem. There's some problem in my business. I'm using AI to solve it. I'm predicting something. I'm doing something for the customer. I'm building a new product that the customer can use that does some generation. I'm doing marketing that's outward facing. It's very rare they look inwards and go, I'm going to actually change my internal processes. I'm going to change how I actually work as an engineer. I'm going to get all my dev teams and I'm going to save them all 30% of the time so they can be 30% more productive. That doesn't tend to be the big, sexy AI use case people go for, but it needs to be on your mind as an engineer. Because most of the time, the AI teams, the data science teams, if you're not the one building the AI, will be looking outwards. Which you as an engineer need to be looking, well, I've got use cases. Why can't we do things on my stuff? So what could you do as an engineer? Well, there's the obvious things. Yeah, you should be working more efficiently. If you're running design workshops, you should be using AI to transcribe it and pull out the actions. You should be using it to help writing stories and comment your code and doing all that stuff. You should be using coding assistants to actually just generate the code in the better way with you having to guide it. The whole thing of thinking of an AI coding assistant as a junior engineer that is great and can write some code, but they need a lot of guidance and need some implicit instructions and you need to check their work. Yeah, it's obvious. And yet people use it really badly and then assume it's terrible and never use it. Or they use it really badly and then they blindly put it into production and it's awful. But those things should be on your list about how you work. Migration assistance, yeah, if you're doing mass migrations, it's almost becoming non-competitive certainly as a consultancy, certainly as an engineer to go, oh no, I do it manually. Migration doesn't really happen manually. anymore. And this has changed in the past maybe 6 months. This is a huge sudden shift that, yeah, hasn't reached every industry yet. But certainly in a year or two, it'll be very rare to find people just manually transcribing code from one language to another. And AI or augmented engineering is what I actually want to talk about, of where we see things going, certainly in the intervening years before more mass-produced, commoditized things come out. Growing amount of AI literacy you need. Not insane amounts, but just how much of it you can actually hop on. So yeah, assistants, yeah, basic stuff. I can get an assistant to write me some bad Spark code that looks like it's Spark code from many, many years ago. I can give it some more information and go, oh, actually, no, I don't want like line terminators. I want just you pass it in as a quag, unpack it properly. Again, even that's bad code, but just the code changes depending on the questions that you ask and how you craft that prompt. As an engineer, you should be getting a big stock of well-crafted prompts that you use when you generate your coding instructions to make your code better. I mean, that's just going to make you better and more effective and faster. And yeah, that might be preaching to the choir and everyone's already doing that. But I keep speaking to engineers who go, no, I don't believe in it. It writes bad code. Because you haven't actually built out those patterns and frameworks. Now that for me is like the minimum. Just as someone who is currently up to date with tech, you should be using workplace efficiency stuff. You should be using meeting transcription. You should be using coding assistance, and that's just going, all the stuff that's not actually technical, kind of just make that like small and tiny so I can get on with the tech stuff. That is like your minimum, you need to be this tall to ride kind of level. So yeah, migrations, we talked about a little bit. So like that whole lift and shift versus a migrate approach. It's what Lakebridge is doing. So Lakebridge, new tool announced by Databricks, is a lift and shift migrator. But it's actually fairly impressive in some of the stuff that it does. Like you'll point it at a system, does a whole scan. We've had like engineered scripted migration scanners for years, comes out with a load of analysis about what can easily be migrated, does the migration using LLMs behind the scenes, spits out the transcribed code in the new format, runs a load of validation testing it. Great, nice, easy. You could have built that in a very scripted way for a certain amount of things, but there's diminishing returns in trying to get every single function in the world written into your migrator, slap it into an LLM. That's going to save us time. You could have built something like this yourself if you're on top of, building agents and starting to use AI judiciously. But that's out. Start using it. Go work with it. It's impressive. Now, yeah, talk about ETL. So talk about a classic medallion architecture type of data pipeline. Might not be the type of data pipelines you're building. Whatever. Take it as an example. How could I be using AI across that thing? Again, most engineers think when we talk about AI, we're talking about the business facing, the use case. I'm trying to do some customer segmentation, trying to extract something from a document. It's I'm doing something to my data because the business wants it. They're not doing what do I do as an engineer and how can I speed that up with AI? So yes, data enrichment is the classic, but all the other bits, like following a quick data pipeline kind of thing, scraping my source system and figuring out how I want to structure that and how I want to layer it out across various layers of my curation pipeline. Taking some data cleansing, looking at my data, doing some sampling and going, oh, actually, I'm going to apply these cleaning rules to it, moving it through. Yeah, it's not going to be perfect, but it might do 80% of the cleaning rules and then I can eyeball it and I can tweak it rather than having to write it from scratch myself. Rather than having to hard code it so it never gets any nuance. We can actually just start using this stuff with a caveat I'll come to in a second. Schema mapping, saying, well, I've got this source tables. I've designed this source schema. Do me a quick source target mapping with a load of extra context about your naming conventions, your existing stuff, some extra context, the metadata behind the scenes, often use cases, a prototype, whatever it happens to be. You can fit that into your prompt or your agentic flow, whatever you're trying to do, to actually make that better. But it does a decent job. Not an amazing job, but a decent job. Someone doing a decent job is better than handcrafting things entirely from yourself, unless it's that bad. Just looking at opportunities of how we can use this stuff. Now, the danger for me is most people, when they're talking about this, they talk about using it as code generation. So if I said that data cleansing example, if I was looking at 100 different tables and going, well, yeah, generate my data pipelines with some code cleansing, people get in their head that I'm talking about spitting out, and we're talking Databricks, spitting out a load, like 100 different PySpark notebooks going, clean this table, clean this table, clean this table, all with the different things hard-coded. That's not how we'd build something. That's not how we'd build something from scratch. You're not going to build that properly. That's not how I'd go about it. Most of the time in PySpark, people build some kind of code-driven, metadata-driven framework because Python you can make nicely parameterized. So actually, we've got this kind of switch. I've got some config in JSON or YAML or whatever, however you wanted to build it, going into a generic block of Spark, and we'll just apply all these transformations and spit it out. That's super common in the world of metadata-driven Spark frameworks, certainly. So we're not talking about generating that PySpark and getting rid of config. We can actually just get our nice generator to generate the config. So I can go, well, make me 100 config files, plug in all the right cleaning rules, go and run it in a loop and spit it out, run the data, show me the data and do some validation for me. I can run that. And a little agent, a little test harness, super, super easy. That is not a lot of work for an engineer. The difference being, yeah, that PySpark little metadata-driven framework needs an engineer to build it. I'm not saying this doesn't require engineering, but I'm saying the amount of work that the engineer has to do, build a small framework, repeat and reuse it for thousands of tables. One small person can do a huge amount. A small team can achieve loads. I think Joe Reese actually put out a blog yesterday saying the new bragging rights is about small teams, not big teams. It's about going, oh, I've got a team of 8 that achieved all this, not a team of 80 or 800. This is what the future looks like in terms of small teams achieving massive amounts. But it's the judicial use of AI to speed up small slices of work around things that we've engineered. Again, to reiterate, not saying data engineering is going away. I'm saying data engineering is fundamentally changing from what it has been for the past 10, 20 years. Slight difference, semantics. So yeah, you can do source document, you can do different things. It's not all plain sailing. You still need to design, you need to think about, well, which LLM are you going to use? How much is it going to cost? Does the cost offset the amount of time you're going to save? And again, salary expectations, if you're going to actually have a smaller team. How accurate is it going to be? What do you need to do to that prompt and to iterate over it so it actually generates config that's good enough for what you're trying to do? Where are you sending your data? If you're trying to get it to do some data evaluation, it's going to look at your data, do some sampling to suggest some cleaning rules. Don't just sling it to ChatGPT because that's outside of your security boundary. You need to design what your approach to actually make sure a real secure governed AI approach is that you engineers can use. And yes, it could be the death of original thinking in the industry if you're relying too much on just asking ChatGPT for the advice for what you should do. There are dangers here. There are things that I'm worried about in terms of where the industry's going because all this stuff's happening. But realistically, if everyone's approaching this, if the world approaches this and we don't stay up with it as engineers, they're just going to go round us and start doing low code, vibe code kind of stuff. The world's going to get full of essentially trash data that looks good, works, but is built by such a spaghetti that you can't actually get behind it and figure out what's going on behind it. We're going to be trying to catch up with what's going. We're going to be replaced by execs who look at this going, oh yeah, this all sounds reasonable. I'm going to swallow the Kool-Aid coming from various different vendors. Maybe I can get rid of all of my data engineers and just vibe code with a bunch of devs and it'll still work because I'll still get data, even if a few years later, it's going to be impossible to actually support. As engineers, we need to get ahead of this and start thinking differently. If you are thinking, nah, I'm still going to be writing PySpark scripts manually, I'm still going to be designing these things manually in a couple of years, nothing's going to change. I'm sorry, I think you're naive. I think there is a fundamentally bigger change happening in industry that we can get ahead of. Data engineering's not dying, but data engineering is changing. It's fundamentally going to be a different thing of actually applying AI judiciously, pulling in the relevant bits, applying governance and good design and architecture principles that various agents and low-code things 6, 7, 8 years down in the future can live in to make sure what they build is actually right and good and sustainable. But it's a very different role than I'm a code monkey sitting there writing a pipeline, making sure it goes fast. Those days, I do think, are going to be dead. Not yet, but soon. So yeah, that was my rant. That was the talk that I gave, which led to all this controversy of me saying data engineering is dead. People assuming I meant SQL's dead. Not at all what I meant. Just that there are products already out on the market. There are techniques people are already using. There are consultancies, vendors, everyone else vying in the AI rat race to get ahead and apply these tools to cut costs. Because honestly, the industry has been horrendous for the past few years. People are trying to figure out how you do more for cheaper, how you get away with fewer people. Do I need a big team to do this, or can I get a small team to actually accelerate it? If you think about the entire offshore model, again, if we can get a cheap resource and they are using AI and they're using skills and they can just automate all this stuff, that is a terrifying proposition if you are an on-prem kind of onshore person actually who is a higher day rate, because people can come for your jobs and because they can bolster their skills and they can do more and achieve more. That is the dire prophetic warning that I was ringing, going, get with it. Learn some new stuff. Have a look at what you're doing. Figure out where you're spending the time and go, we can do that faster. We can make that quicker. Now, on board the hype train, I have been referring to this as data intelligence engineering, just to differentiate. You've got old school data engineering, where you're writing a load of scripts, or you got data intelligence engineering of applying AI judiciously to achieve the same original goals as data engineering. I don't care if no one picks up that term. I don't care if you hate that term with a passion. I care that as an industry, we actually get ahead of this thing and we make sure that we are still a thriving industry within the next 5-10 years. What we do. So, if you stayed with me this long, thank you very much. If you still hate entirely everything I'm saying, in that you don't think it's going to come to pass, I don't care whether you're happy about it. I care whether you think it's going to come to pass. Well, if you don't believe me, great. If it doesn't come to pass, nothing's really going to change. If you don't believe me, but I'm right, and you don't get ahead of this, some of the stuff, you're going to struggle to find yourself relevant. You're going to struggle to be competitive against people who are using this stuff. And if you believe me and I'm right, well then hopefully we're building some really, really cool stuff in the next 6, 7, 8 years. Right, that's all I had to say. As always, thanks for watching. Cheers.